what I wanted to cover was the binomial distribution. So this is a distribution that allows you to calculate the probability of events happening. It's closely related to the flipping of coins, and it depends on you having the event either happening or not. So it's called binomial because there are two choices. Either it does happen or it doesn't. It doesn't mean that you have to have equal probability for it happening and not happening, but most of the time the probabilities are not very small. If you have probabilities that are very small, the binomial starts to break down and you start to need to use alternative methods. So I need to be able to teach you when to use it, how to calculate probabilities from it, and to understand how it's related to the normal distribution. Now, you can calculate the probability for a small number of events like rolling die or flipping coins using addition and multiplication rules. But when you get a large number of events happening, then that becomes very tedious. So when you have an event that can or cannot occur an R number of times in n events where n is large, you don't want to be sitting down and doing the multiplication or addition rules to try and find out the result. So you can work out the probability of at least R successful trials, or less, usually you calculate actually less than R successful trials using this thing called the binomial distribution. Now, if I want to work out the probability of a success R number of times out of n, it will depend on the number of times I try, number of trials I do, which is my n, and the probability of it happening. So what's the probability of rolling 1 6 on 6 dice? Now this is usually an entrance question that they ask, an interview question that they ask in Oxford in the Department of Statistics, because a lot of people fall into this trap. If I roll 1 die, the chance of a 6 is 1 over 6. If I roll 2 die, they're going, well, there's 2 possibilities, so I add those two together, so I've got 1 over 6 plus 1 over 6, so it's 2 over 6. So if I roll 6 die, then it should be 1 over 6 plus 1 over 6, so it should be 6 over 6, which is 1, which is the highest probability you should get. So that's saying that if I roll 6 die, I should definitely get a 6. But you know, in reality, that doesn't happen. You can roll the die so that you don't have a 6 appearing on any of them. So in that particular case, what you've got done is rolled your 6 times, and you've got a probability of a success 0 times. So you can calculate that using the binomial. Now, in general, the probability for any single trial should be greater than 0.01, so greater than frequency in the population of 1%. So examples of using binomial in biology is, what's the probability of finding 10 tryptophan residues in a protein that's 100 amino acids long if the frequency of tryptophan across all proteins is 1%? So that is a very unlikely event. What's the probability of getting 4 men in a sample of 65 people if there's equal frequencies of men and women? This seems a bit of an unusual example, but it happened in one of my classes. I had a class which had 4 men and 65 women. So that leads to the question, are men and women equally likely to occur in biology classes? Answer, possibly not. You can also use it for working out the probability of having a child with Huntington's chorea if I have 3 children, and I know that there's carriers of the disease within my family. And this was a question that came up from a professor in biology called Michael Eisen, and this is him calculating the probability of having no women amongst 27 authors on a paper in Nature. So the probability of that happening by chance is 1.4 times 10 to the minus 8. In this case, he's used a program, well, he's used Python, and he's used NumPy, which is numerical Python, to do the calculation, and we're going to use Excel or R to do it. So you can use the binomial as a hypothesis test. Hypothesis test is saying, is this does this thing have a reasonable possibility of happening by chance? So what's the probability of you getting 4 men out of 65 in a class? Does that have a probability which you think is reasonable, or do you think that something strange is happening? If your probability is low enough, then you find that that is an outlier, and you can reject your hypothesis that there's an equal number of men and women within the class.